Let's talk about inverse functions. So first of all, in our vocabulary, one-to-one functions are just functions where every x has a y. So -2 goes with 1 in this case, -1 goes with 8, 2 goes with 6, etc. If I want to talk about inverse functions, in an inverse function, the x and the y switch. So if I want to write the inverse function of g here, I'll use this little -1 to indicate an inverse, and I would just swap the numbers. So all the y's become x's, and all the x's become y's. Like that. And so in the problem here where I want to know the inverse of g of 9, I'm just going to look in my inverse here to find where I have a 9 in my new x's, and so the inverse of that is going to be 5. I have to look at the actual new inverse function that I have created by swapping all of the x's and all of the y's. All right, if I want to know the inverse of h and it's an equation, here's what I will do. So I'm going to write this with a y instead of an h of x. So I have y equals a -x minus 13 over 5. And what I'm going to do to create the inverse is I'm going to swap where the x and the y are. So I'm going to say x equals a -y minus 13 over 5. And now what do I need to do is go ahead and solve for y. I have to get y by itself again. And so I'm going to, in this case, I'm going to multiply by 5. So I get 5x equals a -y minus 13. And I'm going to add 13. So I get 5x plus 13 equals a -y. We never want to have a -y, and so I'm going to multiply both sides by -1, however you want to do that. I keep writing that, I don't know why. Like that. You can divide by -1, you can multiply by -1, but what we're going to end up with is positive y, and then we're going to have, you could keep your negative on the outside of parentheses, or you could write -5x minus 13 equals y, but that will be your h inverse, and you will write that in here. I kind of like leaving that negative on the outside of this, but if you want to distribute that and change all the signs, you can. All right, so this is the next thing, and hopefully you've seen the lesson where we talked about this notation. This means the inverse of h follows the h of 7. And so what happens is if we plug 7 into our h equation, and then we take that result and we plug it into the inverse equation, when we have true inverses, we will always get the same number. And so I could actually demonstrate that for you. Let's just do that. 7 goes into our h, so we would have h of x, or the h of 7, equals a -7 minus 13 divided by 5. So being careful with our negatives here, we have -20 divided by 5, which is -4, equals the h of 7. And then we're going to input that into our inverse function. And we already wrote our inverse function in the answer there. And so we're going to say the inverse function, we're plugging in a -4, is going to look like this, a -5 times -4 plus 13. to do that math, 5 times negative 4 is negative 20. Negative 20 plus 13 is a negative 7. And we still have a negative on the outside of the parentheses, so a negative 7 is just plain old 7. We already wrote that in our answer right here. Hopefully that helps. I know inverses can be confusing, but they're not that complicated. They're just about swapping the x and the y.